everyone, in previous class we are discussed all about the classification of an elements, and next I am going to discuss with you the periodic trends in the properties of an elements. This is a very important concept to you guys because most of the questions comes from this concept only. Just remember the point, or did you know that there are 18 groups and 7 periods in a modern periodic table, and every particular groups have elements with a similar properties. Just remember this point. Let's come to the point, periodic trends in a properties. What do you mean by periodic trends? Already you know that. Once again I wish to repeat here. Just consider this is a first group. We are having lithium here. After some elements, after some regular intervals, sodium will come under the lithium, and lithium and sodium are having similar properties in between them. And next, again after some interval, the potassium element will came here, and potassium also having similar properties like a lithium and sodium. So like this, some regular intervals and after some elements, the similar properties are repeated. So these are called as periodic trends. And some properties are various from top to bottom, means along with the groups, and some properties are various from left to right, means along with the periods. So what are those properties and how it varies? Let us see some periodic trends in physical properties like atomic radius, ionic radius, ionization enthalpy, electron gain enthalpy, electronegativity, and some periodic trends in chemical properties also here like oxidation states, anomalous properties of a second period elements, and some trends in chemical reactivity. In this class, I am going to discuss with you the physical properties, means the periodic trends in physical properties. First, I wish to start with the atomic radius. In your earlier class, you know the definition of atomic radius like this. This is a nucleus. These are the shell. This is the outermost shell of this atom. The distance between the nucleus and the outermost shell of this atom, this is called as an atomic radius. So this is the atomic radius of the atom. But the measurement of radius of this single atom is not possible here, because already you know that there is no definite circular paths around the nucleus to revolve the electrons around the nucleus, and already you know that the electrons are having a particle nature and as well as a wave nature, means the electrons move around the nucleus like this. So we can't measure a single atom radius. Then how we measure the radius of the atom? So what is the definition of atomic radius? Just see here. It is defined as half of the intermolecular distance between the two atoms. Then what happens here guys, when the atoms are in a combined state? Just observe here, consider this is the atom A and it binds with the atom B. Then how we measure the atomic radius? Observe here. So these are the nucleus of this atom A and the atom B. And this is the distance between these two atoms, and its value is d. Then the atomic radius is equals to d by 2, means half of this internuclear distance. So what do you mean by internuclear distance? Just remember, this is the extra point guys. There are the terms inter and intra. Inter means in between the two objects, means this is a one atom and this is another atom. So in between these two atoms, just consider this is a one tree and this is also one tree. So this is a different tree and this is also a different tree. In between these two trees are inter distance between these trees. Means inter means in between two objects. Intra means within the object. Just consider this is a one tree. We are having so many leaves in this tree. Means this leaf is intra. This leaf is intra. Intra means within the object. Inter means in between two objects. Just this is an extra term. And next, come to the point, guys. I wish to say the definition of atomic radius here. Atomic radius is defined as half of the internuclear distance between the two atoms. So these are the two atoms. This is the internuclear distance between these two atoms, and half of this internuclear distance between the two atoms is called as an atomic radius. So this type we measure the atomic radius. And there are so many bonding types, already you know that. So based on their types of atomic bonding, there are three types of atomic radius, means covalent radius and metallic radius and van der Waals radius. So covalent radius we see in a non-metals, means almost all in a non-metals the covalent bondings takes place, and in a metals we observe the metallic radius, and in a noble gas we observe van der Waals radius. First I wish to explain covalent radius. So what do you mean by covalent radius? So before we are going to know the meaning of covalent radius, first you know how the covalent bond is formed or takes place. Consider this is a hydrogen atom and it's having one electron, and this is another hydrogen atom. Then how the bonds takes place here? This hydrogen also share the bonds with this hydrogen. So like this, means the atoms are overlap each other. By overlapping and by sharing of an electrons, the covalent bond will be formed here. Then I wish to draw another diagram here to now clear concept. Just consider this is a hydrogen and this is the nucleus of this hydrogen atom, and this is the electron, and this is also another hydrogen atom. This is the nucleus of this hydrogen atom, and this is the electron of this hydrogen atom. And how the covalent bond will takes place here? These hydrogens are share the electrons each other like this. So these electrons are shared in between the two atoms. By overlapping of atoms and by sharing of electrons, the covalent bond will be formed. Then we consider these internuclear distance, means HA, HB, HA plus HB divided by 2, means half of this internuclear distance is called as a covalent radius. Just come to this definition. Covalent radius, it is defined as half of the internuclear distance between the two nuclei atoms bonded by a single covalent bond. Observe here, there is a single covalent bond is formed, means here we take half of the internuclear distance between the two nuclei where the covalent bond is formed. So this is the meaning of covalent radius. And next one is the metallic radius. In the metal, the atoms are arranged like this in a crystal or in a lattice. So this is the atom A and this is the atom B of the metal, and these are bonded like this. Then we got the internuclear distance between these two atoms, and we half this distance and get the atomic radius. So this is the meaning of metallic radius. So just I wish to read this definition. Metallic radius, half of the internuclear distance between the nuclei of two adjacent atoms. So these are the two adjacent atoms in a metallic crystal. So this is the metallic crystal. So these are the two adjacent atoms, and we take half of the two internuclear distance of these atoms. So this is known as a metallic radius. And next one is van der Waals radius. Means this radius measured in noble gases. Already you know that noble gases are called as an inert gases. Inert gases. Means noble gases are not involved in a bonding with another atoms. They are inert and they are more stable. So consider this is an atom of a noble gas, and this is also another atom of the noble gas. So they come close to each other but not bonded with each other. So like this, here also we measure these internuclear distance and we get half the value of this distance. Then we get van der Waals radius or atomic radius. Just I wish to read the definition. Van der Waals radius, internuclear distance between the nuclei of two adjacent non-bonded atoms of neighboring molecules in this solid state. This is called as a van der Waals radius. Then how atomic radiuses vary from top to bottom, means along with the group, and how it varies from left to right along with the period, and why. Just see here. Atomic radius decreases across the period, means from left to right side of the periodic table, what happened? The atomic radius decreases. Here atomic radius is measured in terms of a picometer, means 10 raised to minus 12. So lithium have a 152 picometer, beryllium 111 picometer, boron 88 picometer, carbon 77 picometer, nitrogen 74 picometer, oxygen 66 picometer, and the fluorine 64 picometer. Just observe, if we are having a large atomic radius, then what happens? The atomic size is also increases. So if we are having small atomic radius, then what happens? The atomic size decreases. So the atomic size also decreases across the period, means from the left to right side of the periodic table. So why the atomic size is decreases? Why atomic radius is decreases across the period? Consider lithium having 3 protons, and we are having the 2 shells here. In a outermost shell there is a 1 electron present in a lithium. So like this, in a beryllium there are 4 protons, and there are also two shells exist, and in a outermost shell we are having 2 electrons in a beryllium. And next, like this, in a boron, so this is having a 5 protons, and here also we are having 2 shells. In our outermost shell we are having 3 electrons. And just observe the pattern, guys. The number of shells are same, but the number of positive charge, means the number of protons are increases. Already you know that in between the electron and the proton there is a electrostatic force of attraction is there. So these protons attract these electrons or pulls these electrons towards itself. So this proton, means these 4 protons are attract these electrons towards itself, and these 5 protons attracted these electrons towards itself. So here what happened, guys? The number of shells are same and the positive charge will be increases. Then what happened? These protons are attract these electrons towards itself. Then automatically these are comes slightly towards the nucleus, means here. Then what happened? Automatically the atomic radius decreases, like means atomic size also decreases. So this is the reason the atomic radius decreases across the period. Just see here. Remember these 2 reasons. The nuclear charge increases and the number of shell is same. And then what about the group? Along the group, the atomic radius increases from top to bottom. Consider lithium, sodium, potassium, rubidium, cesium. Here what happened? In a lithium we are having 2 shells. So the outermost electron present in a second shell. And in a sodium, the outermost electron present in a third shell. In a potassium, the outermost electron present in a fourth shell. So likewise, from top to bottom, the number of shells increases and the distance between the nucleus and electron is obviously increases. Where the number of shell increases, the distance between the nucleus and electrons obviously increases. So along the group, atomic radius increases, means atomic size also increases. So this is the reason the atomic radius increases from top to bottom. Just remember remember this trend, means the atomic radius decreases across the period from left to right of the periodic table because of the nuclear charges increases along the period and the number of shell is same along the period. And the atomic radius increases along the group from top to bottom because the number of shell increases as we move from top to bottom. So these are the reason, and this is the trend of the atomic radius or atomic size. Now let's talk about the ionic radius. First you have to know about the meaning of ion, cation and anion. So what is the meaning of ion here? Consider this is our atom. If you add one electron to this or you remove one electron from this atom, then it becomes ion. Either it may be a cation or it may be an anion. Just remember one thing, guys, if you remove an electron from an atom or if you add one electron to the atom, then it becomes ion. And next, what do you mean by cation? Consider this is a sodium atom having the atomic number 11. If you remove one electron from this sodium atom, then it becomes cation. So how many electrons are removed here? Only one electron removed from the sodium atom. So only one positive charge will be came here. So sodium Na plus is cation. The atom carrying a positive charge called as a cation. How it carry the positive charge? When the removal of an electron takes place, then only it carries the positive charge, and this ion is called as a cation. I hope you clear about the concept of cation. And next we are moving with the anion. Consider the atom fluorine and its atomic number is 9. If you add electron to this fluorine atom, then the atomic number or the number of electrons become 10, and this become F minus. So this is the fluorine ion, this is the fluorine atom. So the atom carries the negative charge called as an anion. So how many electrons you add here? Only one electron you add here. So this is, sorry, I mentioned only one negative sign is there. So F minus fluorine ion is a anion. Just I wish to repeat, to the atom, if the removal of an electron takes place, then what happen? It carries the positive charge called as a cation. When we add the electron to the atom, then it carries the negative charge and then it become anion. And next another example is that the atomic number of an oxygen atom is 8. If you add 2 electrons to this atom, then what happens? It becomes O2 minus, or you can write like this also, O2 minus. So how many electrons you add to this oxygen atom? 2 electrons. So I write as a 2 minus, O2 minus. So this is about the ion, cation and anion. And next come to the point, ionic radius. The ionic radii can be estimated by measuring the distance between the cations and anions in ionic crystals. Already you know that when removal of an electron takes place from the atom, then the cations are formed, and the gain of electron or the addition of electrons takes place to the atom, then it called an anion. Consider this is the cationic crystal, means here we are having the sodium cations. If we measure the distance between these cations, then we estimate the ionic radii. Remember the point, this is the very important point guys. The ionic radii of an element exhibit the same trends as in an atomic radii. How the atomic radii along the period decreases and with the group increases. Like this, the ionic radii also decreases along the period and increases with a group. Just remember the point guys. And next, cation is always smaller than the parent atom. Cation means cationic radius. Consider this is the sodium atom having 11 protons in its nucleus, and these are the shells having the electrons. Just consider this is the outermost shell having one electron, and the distance between the nucleus and this outermost shell is, just consider, 186 picometer. Already you know that the protons carries the positive charge and the electrons carries the negative charge. There is some electrostatic force of attraction is there, means these protons are attracted these electrons towards itself. And if you remove this electron, what happened guys? Here we are having 11 protons only, but we are having 10 electrons in their various shell. We are having 10 electrons in their various shell. Then what happened? The 11 protons attract these 10 electrons towards itself. Then automatically what happened? The distance between the protons and these electrons, or the distance between the nucleus and the outermost shell, become less. So it becomes 95 picometer. Once again I wish to repeat here. In the sodium atom, we are having 11 protons, 11 electrons. So the 11 protons attract 11 electrons. So here what happened? In a sodium plus ion, we are having 11 protons, but we are having 10 electrons. So the 11 protons attract the 10 electrons itself. Then automatically the size is, or the ionic radii is decreases. So like this, the cationic radii is always smaller than its parent ion. So this is the parent atom. So from this atom we got a Na plus. So this is called as a cation, and this is its parent ion. Just remember the point. The cation is always smaller than the parent ion. So like this, the anion is always greater than parent atom. Just observe here. Consider the fluorine atom. We are having 9 protons in its nucleus and 9 electrons in various shells. And the distance between the outermost shell and the fluorine, its atomic radius is 64 picometer. 64 picometer. And then what happened in a fluorine ion? So this is our anion. Here in its nucleus again we are having a 9 protons, but we are adding a 1 electron here. In the shell we are having 10 electrons. 10 electrons. Just observe the guys. Here the nuclear charge, means the positive charge is increases and it attracts the electrons towards itself. So the ionic radii is decreases. So here what happened guys? 9 proton attract 9 electrons towards itself. Here 9 proton attracts 10 electrons towards itself. And the nuclear charges decreases compared to these electrons and protons. Here we are having a 9 proton, 10 electron. Here what happened? The nuclear charges decreases. And another point is there, if we add an electron here, already we are having the electron here, and then we add a 1 electron. Then what happened? This electron also contains a negative charge, and this electron also contains the negative charge. Then the negative charge means the electrons, in between the electrons, repulsive force is there. Consider this is the electron, this is the electron. So this is also having a negative charge and this is also having the negative charge. Then what happened? It repelled each other. Then what happened? The two reasons are there. One, the repulsive force in between these electrons, this electron and this electron. So it repel and it go away from the nucleus, and the nuclear charges decreases here. Only 9 protons are having the force of attraction on the 10 electrons. Automatically the energy of the nuclear charge will be less here. Again it goes away from the nucleus. Then automatically the distance between the nucleus and the outermost cell, which present its extra electron here, then it becomes, its ionic radii becomes 136 picometer. So like this, cations always smaller than this parent ion, and anions always bigger or greater than its parent atom. Just observe here the point. Cation always smaller than the parent atom and anion always greater than the parent atom. If they ask a question like this, iodine, cation and anion, according to their ionic radii and atomic radius, just arrange the decreasing following. Already you know that anion is bigger than its parent atom and cation is smaller than its parent atom. So this is the way of decreasing order of their ionic radii. Just try to arrange O2 minus, O and O minus. Just try this, guys. I hope you got the answer. Here I wish to explain this. In an oxygen atom, we are having 8 protons and 8 electrons. And in a O2 minus, here we are having 8 protons but 10 electrons. In a O minus, here also we are having 8 protons but 9 electrons. Just to consider the 8 protons means the nuclear charge is decreases, too much decreases in this case and decreases in this case. Here we are having a neutral atom, 8 protons and 8 electrons. So like this, how the negative charge increases, likewise the radius also, the ionic radii also increases. So its order is O2 minus is greater than O minus. O minus is greater than oxygen. If the positive charge, consider a general electron A plus 2, A plus 3. How the positive charge increases, the ionic radii decreases, because the removal of an electron takes place, then the nuclear charge will be increases. Consider A atom having 10 protons and 10 electrons. And A plus 2 means here that we are having 10 protons but 8 electrons. Here we are having 10 protons but we remove 3 electrons here. So here we are having 7 electrons. The nuclear charge will remain same in 3 species but the electrons is decreases. Here what happened? The nuclear charge is increases and the nuclear charge is again too much increases. 10 protons attract 7 electrons and 10 protons attract 8 electrons towards itself, then what happens? The 10 protons attract the 7 electrons, then the radius will be smaller than this species, and this radius will be smaller than this species. Just this is a general example, guys, to know the concept very well. Just remember how the positive charge increases, the ionic radii decreases. I hope you are clear about these 2 points. And another point is that this is the very important point, guys. Just remember, some atoms and ions which contain the same number of electrons, we call them isoelectronic species. For example, consider here we are having a O2 minus, fluorine minus, Na plus and the Mg. First I wish to write their atomic number. The oxygen atomic number is 8. Fluorine atomic number is 9. Sodium atomic number is 11. Magnesium atomic number is 12. And next, here O2 minus means here we are adding the 2 electrons. Here we are adding the 2 electrons. Then how many electrons are in this ion? 10 electrons. And here we are having a 1 negative charge, means we add 1 electron. How many electrons are present in there? F minus 10 electron. And sodium plus positive charge means here we remove 1 electron. Then what happened? 10 electrons. Mg plus 2. This is Mg plus 2. The atomic number of magnesium is 12. Plus 2 means here we remove the 2 electron from this magnesium. Then what happens? Again we are having a 10 electrons. Just observe, guys, in a O2 minus 10 electron, F minus 10 electron, Na plus 10 electron, Mg2 plus 10 electron. There are the different species, but we are having the same number of electrons. So these species are called as an isoelectronic species. The atoms and the ions, either it may be a cation or it may be an anion, or it is a neutral atom. So wherever these species are having the same number of electron, so these species are called as an isoelectronic species. This is all about the ionic radius, guys. I hope you got the clear concept very well about this ionic radii. And then next we are moving with ionization enthalpy.